Hi everybody and welcome. Today we're going to be talking about trigonometry, and the three trig ratios that we're going to be using today are sine, cosine, and tangent. So after watching this video today, you should have a good understanding of what trigonometry is and also how to apply sine, cosine, and tangent. So to start off, we're going to define trigonometry. It's often abbreviated as trig, so you can go either way. Either trig or trigonometry are totally fine. And this is the ratio of the lengths of two sides of a right triangle. And a couple things to note here. It does specifically need to be a right triangle, and we are looking again at ratios of two sides. So if we're going to look at one, we'll draw an example. Here is a right triangle. And let's say that we're looking at this angle right here, angle X. Opposite from angle X, or directly across from it, we're going to call this the opposite leg. Our hypotenuse is still our hypotenuse, so the longest side across from the 90-degree angle, still the hypotenuse. And then now, the side that's directly next to the angle, we're going to call that our adjacent side. So adjacent means we're next to the angle, opposite means we're directly across from the angle, and hypotenuse is still just the longest side. So what this is going to mean, and you can see that in the diagram right below, is again, here's our angle, across from it is the opposite, directly next to it is our adjacent. And this is how we basically use sine, cosine, and tangent. So if you've ever heard of SOHCAHTOA, that's the idea, is that sine is opposite over hypotenuse, so that's the SO. So if this was, let's say, I don't know, maybe this is a 3, 4, 5 triangle. And if this is a 3, 4, 5 triangle, then we know if we're looking at the sine of this angle, it's the opposite over the hypotenuse, or it would be 3 over 5. If we keep going with that, what we're going to see for cosine is it would be the adjacent over the hypotenuse, or it would be 4 over 5 in that case. And then finally, tangent, we would have opposite over adjacent, or it would be 3 over 4. So we're going to be going over a lot of these different examples, but when we're getting to opposite and hypotenuse, we're just looking for what are these side lengths. And the ratio of those, that's the sine, that's the cosine, that's the tangent. So definitely something that we're going to want to have written down in our notes for this table with sine, cosine, and tangent. And again, also really important to have the vocab down to know what is the opposite, what is the adjacent, and what is the hypotenuse side. But again, SOHCAHTOA is a good thing to remember because that's going to help you keep track of sine, cosine, and tangent. All right, so let's go into some examples. For our first one here, they're asking us for all of the trig ratios for angle X. So angle X is right here, so we want to know what is the sine of X, what is the cosine of X, and finally, what is the tangent of X? Well, first let's label. 32 is our O, or our opposite. 24 is our A, or our adjacent. And 40 is our H value. So is opposite over hypotenuse. For cosine, it's SOHCAH, so it's adjacent over hypotenuse. And then tangent is TOA, or opposite over adjacent. And if SOHCAHTOA doesn't help you, that's fine. You can just memorize that it's opposite over hypotenuse, adjacent over hypotenuse, and then opposite over adjacent. That totally works as well. All right, so opposite side length is 32. Hypotenuse is 40. Adjacent side length is 24. Hypotenuse is still 40. Opposite is 32. Adjacent is 24. So you can see that those are actually the answers for each of these. You could divide it to get a decimal, for example. So if we did like 32 divided by 40, our final answer for this one is 0.8. Our cosine here, if we divided this out, would get us 0.6. And our tangent would get us 1.3 repeating. So those are your three answers for sine, cosine, and tangent. So now it's your job to do the same thing. You'll have to fill this in for the next triangle is for angle X, again right here, our opposite our adjacent, and our hypotenuse, and define those three values. Next, you can also do this with your calculator, and I'll go over it both ways, both when you punch it in what happens, but also what this is actually referring to. So let's say we had a triangle, and we had a measure of 90, we had a 30 degree, which means our other side is 60 degrees. Well, if you remember back to the video from a few days ago, we actually know the side lengths of this triangle. This is a 1, 2, root 3 special right triangle example. So the sine of 30 here is going to be opposite, which is 1, over our hypotenuse, which is 2. So our sine for this should be 0.5. Well, if you go to your calculator, you should see on it the SIN or sine button. If you just press that and then type in the degrees, so sine of 30 degrees, what you're going to see is it's actually equal to 0.5. So that's a way to check your work there. So now it's going to be your job to basically play around with that a little bit. Let's type in the value for cosine of 88 degrees and then tangent of 10 degrees. Doing those two things, that'll get you answers, and that's what your answers mean. Is they're basically going to create these triangles in the calculator and then do the math of the sine, the cosine, or the tangent based off of those side lengths, which are based off the angles. The last thing that we're going to do today is a little bit of solving. So we'll go over this first example, and then you'll have the opportunity to finish up the rest of this here. So we don't know what x is. They're giving us that this angle is 21, but we do have the side length here. So that side length, that's our longest side length, that is the hypotenuse. The side across from 21, that's going to be our opposite. So we know we can use sine, because sine uses the opposite over the hypotenuse. So our opposite is x, and our hypotenuse is 22, and the angle that we're measuring is 21. So let me highlight where each of these things came from. That's our angle. That's our opposite. And then this is our hypotenuse right here. So basically what we can do in our calculator now is actually punch in sine of 21, get a value for that because we know that that's going to equal x over 22. So let's actually go through and start solving this. So back to the calculator, sine 21 degrees gets us 0.358. All of that equals x over 22. We want to get x by itself, so we need to multiply both sides by 22. That'll cancel out there. So we'll basically be multiplying that 0.358 by 22. We'll get an answer of 7.88 for x. And basically by setting up that proportion, we can solve for any unknowns. So if we have an unknown here, we just did some algebra to solve for that. But if the unknown was in either of the other two spots where the 21 or the 22 is, we'd be able to basically do the same process and solve for that as well. So that's going to be your job going through the next two. You're going to have to identify, do you need to use the sine, do you need to use the cosine, do you need to use the tangent, based off of what you're given. Because we were given O and H, we need to use sine. But if you're given, let's say, opposite and adjacent, then you need to use tangent. All right, everybody, hopefully that helps. If you have any questions, as always, don't hesitate to reach out. We are here to help. A new day with trigonometry, some good practice here today, and I'll see you all in Teams very soon. Thanks for tuning in.